My name is Misael Benjamin Emmanuel Telling from Mathematics 23, and in this video I will summarize the presentation from Professor Seiya Negami, with the presentation title Graph Coverings and their applications. A covering graph is a subgraph which contains either all the vertices or all the edges corresponding to some other graph. A subgraph which contains all the vertices is called a line-edge covering. A subgraph which contains all the edges is called a vertex covering. In the mathematical discipline of graph theory, a graph C is a covering graph of another graph G if there is a covering map from the vertex set of C to the vertex set of G. A planar cover of a graph is a finite covering graph that is itself a planar graph. The property of having a planar cover may be characterized by forbidden minors, but the exact characterization of this form remains unknown. Every graph with an embedding in the projective plane has a planar cover coming from the orientable double cover of the projective plane. In 1988, Seiya Negami conjectured that these are the only graphs with planar covers, but this remains unproven. In graph theory, a planar cover of a finite graph G is a finite covering graph of G that is itself a planar graph. Every graph that can be embedded into the projective plane has a planar cover. An unsolved conjecture of Seiya Negami states that these are the only graphs with planar covers. The existence of a planar cover is a minor closed graph property, and so can be characterized by finitely many forbidden minors, but the exact set of forbidden minors is not known. For the same reason, there exists a polynomial time algorithm for testing whether a given graph has a planar cover, but an explicit description of this algorithm is not known. For the example, the graph of the dodecahedron has a symmetry that maps each vertex to the antipodal vertex. The set of antipodal pairs of vertices and their adjacencies can itself be viewed as a graph, the Peterson graph. The dodecahedron forms a planar cover of this non-planar graph. As this example shows, not every graph with a planar cover is itself planar. However, when a planar graph covers a non-planar one, the pli must be an even number.
With my head again, you had your heart set on me, but these feels, they come and go, and they come so easily. Tell me what it is about you that I can't forget, but you're breaking down my walls again, just to set me free. Why do I, baby, why do I love the way you always leave me? Why do I, baby, why do I love the touch with